Yesterday we have done with libraries like NumPy and Pandas to do data analysis and mathematical operations. Now we will start with the libraries of Matplotlib, Seaborn, and sklearn to plot different type of graphs to visualize the data. And if you have any doubt related to previous session of NumPy and Pandas library, you can ask. So I will start with the Matplotlib library here. So firstly, we have to import the library as PLT. Matplotlib.pyplot is a library. We have to import it as PLT. And NumPy is also imported here, and math module also. So first we will learn how to make a simple line plot using PLT library. And here I have defined x values manually. The line space command will give 20 values between 0 to 20. Create 20 numbers between 0 to 20, and the subplot command, sorry, and the by values command will provide the square root of these numbers. You can also print the x values by print command. So you can visualize what I've done behind the calculation. So you can print x values and y values by providing print command over the x values and y values. So here the x values are 20 numbers, and the for loop has been provided for math square root of I for I in x values. So it will take square root of every value in x values, and y2 values are cube of x values for every value of in x values array. Then we will provide the figure size. PLT.figure will create a figure window for our graph, and figure size 53 will provide the scale of the graph. So our graph will be of 5 inches width and 3 inches height. And the x label command will provide axis label, and y label command provide y axis label. You can provide a label according to, you can take different function also, like x plus y, x minus y, and different mathematical functions, sin x, cos x. And the title command will provide the title to the graph, and plt.plot command will plot the graph. So the first value will be which takes value from the x-axis. So the x values takes the value from x-axis. So we will provide it first. And second value is y values, which is take values from y-axis. And R is for the color. R represent red color. And label is the label of the line. Like red color line label will be square root, because it is a square root function. And plt.plot command for y2 values, which is q function. So plt.command will plot the q function. B represent the blue color, and label is representing that blue color line is showing the q function. And legends are these. The box what is showing at red is square root. If we don't put the command plt.legend, the box will not shown here. And plt.shapeFigure is command to save the figure. Now, what if I want to save the figure in my PC? So you have to put this command. The figure will save here. Please run it, and plt.savefigure, the figure file will shown here, and put on 3 dots of the figure file. Now you can download the figure from here. Just a minute, you can see how the figure can be downloaded. Yeah. So we have provided the name iris plots. So the file will be seen here, and you can download from here. It will be downloaded in your download section. Then you can use it in your files and reports also. Please type these commands and plot this graph in your code cell. and let me know if you have any doubt or any error. So now we will proceed with the subplots. Again, import. We do not have to import again and again. Just I import it because if the memory has lost, it will not cause any error. So from sklearn dot datasets, we have imported iris data. We also have learned the sklearn library uses previously. And load iris function will load the iris data in iris variable. Then iris variable have three features: data, feature names, and target. Then df pt.data frame will create a data frame which will stored in df, and target variable will store in df target. So df is a list type of data frame. In target column, the targets of 0, 1, 2 classes will be stored. So now we have to plot subplots. Subplots means if I want to plot 4 or 5 plots in a single frame. So for subplots, the command is first we will it is a single plot contains different types of graphs. So the first we have to define the figure. Plt dot figure will define the figure, and figure size 10 for will give the figure size. And the subtitle command is the combined title for these figures. Previously, we have defined only plt.title because we have only one figure. The subtitle command will define the whole figure. And now subplot command, plt.subplot 1 to 1. So the 1 to 1 is representing here the first index 1 is representing number of rows, and second is representing number of columns, and third is representing the index. So if I want two figures like in two rows, first is above, second is below, then I provided the first index as 2. That means the two figures will shown as first is above, second is below, and second number is showing the number of columns. So if I want two figure like that, then 2 is replaced by 1. And first is index. Like this subplot will shown as first index. Like an array, you can understand by an array, this subplot command. So the plt.scatter command will plot a scatter plot, the point by point plot, and it will contain in a variable scatter. And the data frame lists the column of sepal length centimeter, and the petal length centimeter will be plotted by the plt.scatter. C is representing the color here, and C map equal to width is the color bar here, color map. You can change it. We have so many color maps in Python, like plasma, cool, warm, lukewarm. Like you can check it. And alpha representing the transparency here. You can change the alpha. I can show you by changing it. If you change the alpha for 0.1, you can see first the graph. The graph is, if I change the alpha, it changes the transparency of plot. You can see the plot is now very blurred. So by changing these parameters, you can see the varieties of attributes in single graph. So please type this plt.scatter command in your code cell and try to plot the same plot which I have shown you. C represents for color, but color provides for which? Hello? Color provides for which category or which column we have to define here. So the DF target means target had three categories, 0, 1 and 2, which is the three variety of flowers. So the color map will define for these three species. And PLT dot color bar scatter, it sets the color bar which is shown here. This is the color bar, the line.
उसमें है ना मैटलैब में ना ऐसी कमांड नहीं होती ना?
Sorry,
लेटेक्स में
Yes.
थोड़ी ऐसी कमांड होती है।
उसमें
yes,
actually
MATLAB
लिखी
में ये
आती
कमांड
है, अंदर का लिखना होता है।
हेलो कौशल उपाध्याय, आप
अंदर आपको लिखना होता है बस।
आप बात कर रहे हैं क्या कौशल उपाध्याय?
सॉरी मैम।
Okay, continue please.
Okay. So you can, I am on color bar, PLT dot color bar, which set a color bar for scatter variable. Label will be target class. Now the color bar will show that the blue one is for target class 0, the green one will for target class 1, and the yellow one will for target class 2. And that's how our plot, our graph has been plotted. And these are the commands for title labels, which is same for all. And PLT dot grid means the grid is visible in the graph. The vertical and horizontal line are grids here. If you don't want it, you can remove this line PLT dot grid. And for the line plot, which is shown here, the right one. So the again, the index of the line plot is 2. 1 row, 2 columns, and second index is the for the line plot. So we have provided PLT dot subplot 1, 2, 2. If I have 4 graphs, let's assume I have 4 graphs, then we have 2 column, 2 rows, and 4 index. Then we can change this also 2, 2, 1. Then for the second graph, 2, 2, 2. Then for the third graph, 2, 2, 3. Then for the fourth graph, 2, 2, 4. That's how we can manage 4 graphs in a single frame. And again, we have plot the PLT dot plot the sepal length and petal length in blue color. P is representing the blue color. This is a line plot. For line plot, we don't have to provide any command. The PLT dot plot will simply plot a line plot. Okay. So I hope you can understand how to plot a scatter plot and the line plot from Python. Now, Mukesh will proceed for the further code forms.
Hello everyone, myself Mukesh. So for next type of charts, we import a new data set called passenger data set. So we read this data and print first 5 rows of data to see how it looks like. So in this data, we have passenger ID who have survived, P classes, names, sex, age, etc. So okay, we want to make a bar chart for between age and gender. Gender is a categorical variable, age is a numerical variable. So for gender, we have male and female 2 entries. And for age, we will take average. So this bar plot, as Rinki ma'am mentioned, 5,4 means size of the figure. And in X level, we want to gender, and in Y level, we want ages. Also, we want to title this plot as gender versus age. So command to make this bar plot is plt.bar and put which column you want to use. So let's say you are using this column sex and age. So you get this diagram. This is called bar plot. So as you can see, for male, this is the average age, and for female, this is the average age. Other things are similar as above. So how to draw a figure? plot dot so next, if you want to see how age is distributed, so you want to draw a histogram. So for this, there is a command dot plot dot hist, and insert the data column which you want to draw. So here we want to draw age. So data and age column. So similarly, plot title we have age distribution. For X level we have age, and for Y level we have frequency. So you got this age distribution. Let's say you want to make it for fair. So nothing, just put fair here. Fair. Okay. Then let's say here we have fair distribution. Okay. Here I want X label to be fair. Okay, then run it. Okay, sorry. We have to run from this. Okay. Okay. We have to upload this. This file is not uploaded. Okay. No such nothing. Give me 1 minute. So you have to upload the file to proceed. Okay. So now run this. So this is how you upload the file. Okay. Now make this bar plot. Okay. Now we want to histogram for fair. So this is uh, distribution of fair. Okay. So let's say you have multiple values. Let's say you have labels like IT, marketing, data science, finance. Each of them contributes some values, like IT contributes 500, marketing contributes 156, and like this. So you want to make a pie chart. So pie chart means you have a circular region in which each part shows how much each part contributes. So for IT, it is 500. It means 34.1%. Okay. So this X plot means 0.05. It means we want to give 0.05 space between two parts, like this. Okay. So, and these are labels: marketing, IT, finance, data science. So command is plot pi, then values. For values, you have this array. For X plot, you have this 0.05 for each part. For labels, you have this first row, and just paste it. So shadow is true, so there is shadow at the corner of the each part. So if you don't want shadows, then type false here. So then plot so, and then you are done. So like you don't want any shadows, so just write false here. Okay, then run. So there is no shadows. Huh? Each part have space 0.05 between them, and there are no shadows. Okay, so let's say you have this value 400, then automatically IT contribution of IT will reduce, and area of this part of IT also reduce. So let's have a look. Okay, so now it's 29.3%. Okay, just like that you can make pie charts. when it required. Okay, so now how you draw a 3D function? So 3D function means you have two arguments, x and y, and you insert them in a function f of x, y and get a single argument. It means 2 plus 1, 3 dimension. So let's say you have a function sine under root x square plus y square. How to plot it? So first import the library, a PLT, import numpy as np, and import x is 3D. So we want to draw this diagram in 3D. So x is equal to np line space. It means a value of x is from -5 to 5, 100, 100 means -5 to 5 means length 10, and we want to divide into in 100 parts. Same for y, -5 to 5, and x comma y is equal to mesh grid. Mesh grid means we want to draw a grid. It means xy axis. We want to draw xy axis is for -5 to 5. So then z we have this function np dot sine. Np dot sine means it will take sine function. And what is the value of sine function? Np dot square root x square plus y square. Then you just have to fig is equal to plot dot figure, and you want it in 3D. So projection is 3D, and camp is nothing but this color. If you want other colors, there are other methods. So this is cool warm, so you can use other colors also. And the similar title surface plot, x level x axis, y level y axis, z level z axis, and you can draw this plot. You can draw any graph like this. Sorry. For next section, Rinki ma'am will proceed.
Hello. So I hope you will understand how to plot a 3D plot by using and PyPlot by using this library. If you have any doubt, you can ask me. I think I should proceed now. So we will learn now Seaborn library. Seaborn library is also a data analysis library. We can also load data sets from this and also plot different types and advanced level of plot, advanced level of graphs from here. So you can see on my screen whenever I will tap on this library, one link has been shown here. Yeah, this link. So because this is Google Cloud online version, you can visit the library source and see how the library works and what the whole advantage of these libraries, whatever you want to do, all commands you can get from here. So you can visit these sources by clicking on the library name on the code cells. Okay. So here, the import the library as SNS, the SNS, NP, and these are the licenses for the library, which are creating simplest form of the libraries. So here we are downloading the fMRI dataset, which is a brain MRI dataset from SNS library. The SNS.load datasets will load the fMRI datasets in the variable fMRI. So first, please load the dataset. Type these two lines and type display, which will display the head of the MRI first 5 values of the fMRI datasets. You can write it. These are the simple 2 lines, and you can visualize your fMRI datasets. You don't have to upload any datasets for this. the SNS, like the loads dataset command will directly take the dataset from SNS library. In pandas, we have to create a data frame. Then we provide the command df.head. If you remember df.head to show the data file. Here, the display command has been shown. To create a line plot, it is a multiple line plot against the two. You can see in the data set, the features are the subjects, time point, event, reason, and signal. So we have created a graph against the time point and signal and taken event and reason as a features. Hello. Hello.
Dr.
So-
B. Mathura, do you have a question? Dr. B. Mathura, you're not audible. We cannot hear you.
Okay. So in event, we have two types of category. One is a stem and second is queue. You can see here. And in reason, we have two type of categories. One is a parietal and second is frontal. So we have plotted a multiple line plot by using SNS.line plot. The HUE command will provide the class separation for reason. Reason has two categories, means two classes. It will separate the categories by colors. So the HUE is equal to reason will provide that, and its style is equal to event. So the line style will provide for event, and the solid line with for stem, and the dashed line for queue category, which is for event, stem, and queue. So from the graph, you can see the blue one line is showing parietal category and stem category together against the signal and time plot. And the blue dashed line showing the queue category and parietal category against these axes, and same for the frontal and stem. Please type this small code and try to see how can we visualize the data using SNS library, and can we plot this line plot using this. So now we will proceed with pair plots. Pair plots are the grid of scatter plots which will represent between every pair, a relation between every pair of features. So we will take iris data for this, which has 4 features. First, load the iris data set from sklearn libraries. And again, create a data frame. These things we already have done. And again, provide the target column. Iris.target will extract the target column from iris data in the data frame of target column. And species will take categorical values and provide these categorical iris.target has categorical values 0, 1, and 2. And iris.target names has text string values, setosa, and 3 types of setosa, versicolor, and virginica. These 3 types of classes, 3 types of flower here. So we will provide these names to the categorical values 0, 1, and 2. And so the species column will take this, and again we plot the sns.pairplot command. Take the data frame df, and I already tell you that the U will show the class separation. So here the species shown the class. Species have 3 classes. So the U will HUE command will show the class separation by different colors. And height 2.5 will show the 2.5 cross 2.5 scale for every plot. Then plt.subtitle subtitle will provide the title for the entire plot, which is shown here, pairwise feature relationships. And Y is showing the position of this title. If you change the value, the position of the title will differ. And plt.show for showing this figure. You can also try to save this figure in your downloads. As I have mentioned before, plt.save figure. Again, one more thing, the diagonal will always show the line plots in the pair plot, and the off diagonal will always show the scatter plots. It is the default version in SNS library. Here, this is the box plot. So again, we have taken the features of iris data set, which is species and petal length for this box plot, and sns.boxplot will plot the command. This box plot is very useful for statistical analysis of data. How? Because these boxes are showing quartiles. The Q1 quartile is the below line is Q1 quartile, and the above line is Q3 quartile. And the quartile difference is shown by the boxes. And the horizontal line is showing the median value for versicolor species for petal length column. So the petal length column for versicolor species have median this. And the points outside these boxes are outliers. 1 or 2 points which have very different values than other values are called outliers. So, okay. And the vertical line will show the range of the values. So the range of the versicolor species of petal length will be from here to here. You can also plot your mean and confidence interval in the box plot to do more statistical analysis on data. So now we will proceed for how to encode data. Because previously we are downloading iris data directly from the sklearn library. So it is ready to use. Like it is encoded already for in the classes 0, 1 and 2. But what if we have raw data file? So here it has been shown how to encode the data to make it understandable for the computer. So just upload the iris data file from here. Every file will be uploaded from here, and just copy the path. The path will be provided in the double and single quotes. So now DF is the data frame of iris data. By printing this, we can see there is no column of 0, 1 and 2 class. There is only column of classes which is shown by text iris, setosa, iris, versicolor, and we have different types of data sets which is showing true, false, yes or no types of categories, but we can't directly put them in a model because it can't be understood by the computer and models. So we have to make it convert into numerical values. So we have created a new column df target here in the df data frame, and take df species, take species column, and dot s type category, treat name as groups. If we talk about setosa, it will all setosa name will be take it as a group. So we have three groups now as type of category. We have three category. So for till now we have three categories, and dot codes will assign a number to each category. So now now you can understand how this will be done. First, we will treat every same text as a group, as a category, then assign a numerical value to it. So we have assigned 0, 1, and 2 values to this category. You can print the whole data by using the print df only. The 150 values will be shown, and you can see the 0, 1, and 2 values will be provided to different classes. Now we will see how to split the data set. So to use the data to train our models on data set, we have to split them in train group and test group. First, we have to train our model and then test it by using the test data set. So we can do this by using sklearn library. From sklearn model selection, import train test split. Train test split command will automatically split your data set as your requirement, and x variable will take only data, not target or species. Here we have two extra column, species and target. We can't take this in data because in label data set we don't provide labels in to models. So we will drop these columns by command the df.drop, and in y column we will provide the numerical values which are the labels for our data. We can call it as output of the data. And to split the data set, we will create 4 group: xtrain variable, xtest variable, ytrain variable, ytest variable. And train test split command will split x as well as y. Y is a one column vector, and x is a matrix of data set. And test size 0.2, which means that 20% data will be goes to test set, and 80% data will be goes to train test. And random state equal to 42 will provide the randomness of the selection of the testing data and training data. It will not select as first 80% is going to train and last 20%, or first 20%. It will take randomly. So you can change the random state 40 to 18 as you want. Now to show how the data has split train feature shape, we can see the shape of this data matrix xtrain, which is 124. So first we have 150 samples. Now in xtrain we have only 120 samples and 4 features. And in a test set we have 30 features and 4 variables, 4 features. And as the target is only a column vector, So it is showing only one value, 120 and 30. Again, we see how to extract the categories from columns of the data sets. So here is a data set tips. We can download it from SNS library. Download the tips dataset from SNS library and print it tips.df.head. It is a restaurant dataset, total bill, tip, sex, smoker, day, time, size. And we will manipulate this data. X contains only the columns by removing the tip column. X is equal to 1 will ensure the removed column will take as a column vector. That's why we are providing x is equal to 1. If we are providing x is equal to 0, then it will take it as a row vector. You can check it. And y will take the tip column. Tips.df tip will provide the in the y variable the tip column. And x.head will print. Now you can see the tip column is not showing in this data, x data. And again, we created a new variable numerical in which x will drop these 4 columns as column vector, and then we will print it. After removing these 4 columns, we have only these 2 columns, total bill and size. Now we will create another data variable categorical, which will filter out these 4 columns and take it in this variable categorical. So the 4 columns are separated and these 2 columns are separated now. Now we can see how to get dummy columns and categorize every column in for the computer. And you can see the day and time has categories. These columns have categories. So we will take dummies of this column. You can, are you all able to see the data set? Okay. So it will create dummy columns for the every category. pd.get dummies categorical will create the categories. So for every column you can see, and it will provide a true false value. Now every column is a single category. If it is true, then it will provide true value, and it is false, then it will provide false value, because the string we can see here will not take it up in a model. Now we have to convert it into the 0, 1 value to make it understandable for programming. So the cat numerical value will take it these columns as an integer type. .s type convert it into an integer. Now you can see the whole data will have converted in binary numbers 0 and 1. Now we will see how to concat the data. We have 2 data sets, numerical and cat numerical. Cat numerical has binary numbers, and numerical previously we have the total bin and size variable. So to concat these data sets, we will provide pd.concat command, and it will concat these 2 data sets, and x is equal to 1 will ensure that data set will be concat as a column vector. So you can see the total bill and size has been joined in this data set, and it has created a new data set for us. So the introduction of basic Python has been done. If you have any doubt till now, you can ask me. Now we will proceed for the linear regression code.
Participants, if you have any doubt, please ask. So, okay, we can proceed to the next part of the session.
Okay. Second. The screen is visible.
Yes, it is visible.
Now we will start the linear regression code. So all of you have get the salary data set on Canvas. You can upload it from here, the salary data set. Just upload the data set. Now import all the necessary libraries. The printing of data set will show, this is a data set of simple regression, which have one dependent variable and one independent variable. So according to the formula of simple regression, simple linear regression, we have to calculate the mean of X and Y columns. First, we have I have two columns here for the data set. The first column of independent variable, which is years of experience of salary, will be inserted into the X variable, and the second column, which is dependent variable salary, will be inserted into the Y variable. Then we have to calculate the mean of both these columns. Statistics.mean will calculate the mean of X column, and statistics.mean will calculate the Y column. And now print the mean of X and Y. Now we have to calculate the slope and intercept. According to the formula, the slope is sum of X minus X mean and Y minus Y mean upon sum of X minus X mean to the square. So the dot sum command will sum up all these entries. X is a column vector here, and mean X will be subtracted from every entry of X. So numerator has been defined here and denominator has been defined according to the formula. Now define the formula of M, numerator upon denominator. And for C, mean of y minus slope and mean of x. So to print the regression line, we have written here regression line y equal to m. M is a variable. We have one value assigned to m, and column will assign the dot colon dot 2f will ensure the value will be printed up to 2 decimal numbers, and x will be print as it is, and c is also a variable. The variable will be in curly brackets always. The print output you can see here, regression line y equal to m value is this and c value is this. X is the independent variable, and slope intercept has been printed here. Now we have to plot actual data in regression line. First, plot is scatter plot for every value of x and y. Years of the independent variable of x, years of experience, will take it as x and on x-axis, and the independent variable will take it on y-axis. So the scatter plot will plot the x data points according to y in blue color, which shown the label actual data. The blue points are actual data, and the fitted line is red line. You can understand the code of plt.plot. We have already learned it. So that's how you can plot a regression line in a graph using Python. I hope you all will able to draw this regression line. Now we will take an example of prediction. Let's take example of input 6.5 years. If I have 6.5 years of experience, then what will be my salary? According to the equation of regression line, then predicted salary will calculate, and it is printed here. That's how you can do the linear regression for simple one variable. Now we will start multiple linear regression. You all have get the advertising data set. Please upload it from here. And read the data set using the pandas library. Now we have to separate the data sets because the labels, the output variables of sales will be not taken up at independent variable. The independent variable are here is TV, radio, newspaper. It is an advertising data set. If we advertise our product on TV, radio, and newspaper, what will be the impact on sales? The data set has been shown this. So in X, we have taken these independent variables of TV, radio, and newspaper advertisement. And in Y, we have taken the independent variable of sales. The sales will be dependent on these three variables. So now we have to create a column of ones for the intercept. So x dot shape 0 will define the number of samples, and np dot ones of x dot shape 0 1 will create a matrix of 1 which have the shape of number of samples and 1 means it is a column vector which has rows as number of columns and 1 column. As of now, and np.c will do the concatenation to of this column of ones to the x. X don't have the sales column because we have removed it. So by printing xp, you can see here we have 3 variables and the 1 column has concatenated here. Now I have printed the y variable up to 5 entries. You can see this is not in an array form. To do mathematical operations, we have to convert it into an array form. So we dot values will extract the values from y column, and dot reshape -1 to 1 will turn into a column vector. Now again printing by v up to 5 values will show it is now converting in a 1 column vector. So now we have to calculate the best parameters of this multiple linear regression. The theta best is the column vector which contains the best parameters, and np.linear algebra lin will do the linear algebra commands here, and np.linalg.inv will do the inverse of xp transpose dot xb. xp is this matrix. If you remember the formula which you have learned in the session of logistic regression, x transpose x inverse dot x transpose y. This is the same. So it is calculated from the linear algebra command, and the theta best is now a column vector of 4 cross 1 shape because we have 3 variables and 1 intercept. So the results of best variables will have 4 cross 1 column vector has 4 entries. To define the prediction function, we have to multiply the xv matrix with the theta best. It can be multiplied because the matrix column has 4 and it has 4 cross 1. So it will predict all the values of the data. So because in first entry we have 1, the multiplies of theta best will provide the intercept. So the theta base 0, the first entry of 0th index will provide the intercept, and to get the coefficient of the beta 0, beta 1, beta 2, beta 3, we have to calculate, we have to extract after 1th entry. So the 1 column will extract the entries of first, second and third. Means for the 1th entry and after the 1th entry, the values will be taken up from the array because theta best is an array in a column vector. The results are printed here, and the equation of prediction is shown here. Sales equal to intercept has been shown here, and the coefficients, first entry of the matrix will be coefficient, first coefficient, and second entry of the matrix will be second coefficient, third entry of this matrix will be third coefficient, and the variable is TV, radio, newspaper. Now we have taken an example of array. We have taken for this type of advertisement, TV, radio, newspaper. What will be the sales? So the predicted sales, we will just dot product with our best parameters, and predicted sales will be calculated. The zeroth index have placed here because predicted sales will be an array. So it is one element, but it is an array. So to extract this, we have to place the index here, and the dot 2f will take up the 2 decimal numbers. So the multiple linear regression has been completed. If you have any doubt till now, please ask.
Participants, any doubt here? Any doubt here?
I hope you all have done these in your code cells. If you all are comfortable with this linear regression code, then we will proceed to the principal component analysis code.
So there is some doubt in the chat box.
First, okay. I want to learn how to make environment in Python in Jupyter Notebook. Okay. By downloading the Jupyter Notebook, you get the 3 dots in upper right corner. You can select the Python 3 environment only, and then you can run these type of codes there. If you have installed the Jupyter Notebook, then after After opening the Jupyter Notebook, you can see the in upper right corner where we upload the files. You can change the Python environment. We have to choose the Python 3 environment.
गाँव में ऐसे तो है कि रोड ये है, मेरे घर के सामने वो रोड है तो मेरा रोड है ये है। और दिल्ली में तो कोई बैन है
वह यहाँ कुछ नहीं है किसी का।
Sabha server, do you have any doubt, Miss Sabha?
So now we will proceed with the PCA code. Is my screen is visible?
You are mute, Rinki.
Hello.
Yes, now we can hear you.
Is the Jupyter Notebook screen is visible?
No.
Okay, I will reshare it. So after open the Jupyter Notebook, you will get this type of interface. Then click on this because I have chosen the Python 3 environment already. So if you are installing especially, then you can choose the Python 3 environment from here. Is it visible now?
Yes, it is visible. So, Miss Pooja, if you can see. So, you can unmute yourself and ask the doubt if you. Yeah, you can unmute yourself and ask the doubt, Miss Pooja Kaplesh.
Yes, you can also choose from the Anaconda surface. The environments list will be shown there if you install the Anaconda platform. But in Jupyter Notebook, you have to select it from here. Okay, so now I will share the PCA code. If anyone has not any doubt. Okay, so let's start. The import warnings will remove the warnings, and the second command warnings, the filtered warnings will ignore the warnings. And again, NumPy, Pandas, and Seaborn has been important. And Matplotlib already imported here. And the figure size is defined. It is not needed here. You can ignore it. Okay, so we will do principal component analysis on breast cancer data. So firstly, we have to import it from the sklearn library. So just type from sklearn.datasets import load breast cancer. You will and from sklearn.preprocessing import the minimax scaler, which will use to standardize the dataset. So first we define a variable which consider the whole data set. So BBB is a variable which contains the whole breast cancer data set and creates a data frame for this breast cancer data set. You can see this data. It is 5 rows. Sorry, it is the head, so it has 5 rows, but it is 31 columns. So the last column is the target. So we can see here the 30 features for the breast cancer data set. And the target column will be considered by the target column of DF data frame. So the Y variable will take only the target column from there because the column of target from data frame DF will be assigned to the Y variable. And df.help will show the table of data set. All of you are able to do it? Okay. Now we will prepare our data for PCA. Input columns will take by removing the last column. This command column -1 will take only all columns by removing the last column only. The last column is the target column, so we don't need it. So we will drop this. You can also drop by df.drop, but the different commands will work. And the input columns will be a list now of these columns. These array, one feature will be work as an array, and the DF is in list which has these type of arrays, 30 arrays. So the inputs DF now have these 30 features only. Don't this does not have any target variable. You can see it has 30 columns. So now a scalar variable will take minimax scalar command, which standardize the features in a single center, because if we do not scale the data, then the result can be biased because the values are different for each feature and each variable. So the scaling command will standardize the data, normalize the data. To do data analysis for this data. After standardize, our results will be more reliable. The scalar.transform command will transform the values. You can see the values has been changed now. Will transform the values according to scale. So now I have created a empty list of column values. And we have run a for loop for I in range of length. len command will calculate the length of this column, input df dot columns. So we have 30 columns. So the len bracket of input df column will return 30. And that means for I in range 30, column values in empty list. So dot append will add values in this dot append. Input df dot I loop will provide the location of entry (I) all rows of column number I. This is empty, that means all rows. This is here is I, so that means ith column of values. That means in empty list of column values, all entries of first we will run for one. So for one column, all entries of one column will be appended in this list. And again, for the second column, all values of the second feature column will be appended in this column values. So that's how we will create a list of arrays which contains the values of every feature. We have done this to create a NumPy array, because to do linear algebra operations like covariance matrix and all, we have to convert it into a NumPy array. Now, calculate the covariance matrix by command np.cov. Now, because the column values is a list of arrays, and list of arrays is always a matrix, NumPy matrix, then np.covariance matrix will be calculated. You can print the covariance matrix by print command and see how it will look like. So when we print the shape of covariance matrix, so we have 30 columns. That 30 features, that means covariance matrix will be 30 cross 30. So the output is 30, 30. Now we will calculate the eigenvalues and eigenvectors. And np.lin ALG command will calculate the eigenvalue and eigenvector of covariance matrix. EIG command will provide eigenvalue and eigenvectors both. That's why we have defined two variables here. Now, according to theory, we have to sort it the eigenvalues in a descending order. I hope you all remember that. And the np.arcsort command will sorted the eigenvalues in ascending order because there is no command for descending order. But the last command of this bracket double column -1 will reverse the order. So first we will sort np.arg sort will ascend the eigenvalues in ascending order, and then we will reverse the order of eigenvalues. It will provide the indices of the sorted eigenvalues in sorted indices. Then entry of this indices will assign the eigenvalues variable. And for eigenvectors, it will provide the vector for the sorted indices. Like first sorted indices is index is 5. Then it will return the fifth eigenvector to the first location. So it will sort the eigenvectors and eigenvalues according to requirement of PCA. Now this is the explained variance ratio by eigenvalues divided by sum of eigenvalues. This is the percentage of explained variance. We have printed the first 5 components of explained variance here. These are the percentages. You can see mostly data can be interpreted by these first 5 components. So we have now come from 30 features to the 5 principal components. This is the work of PCA. XPCA will be variable which project the eigenvectors up to 2 columns, 2 eigenvectors. The eigenvectors are sorted now. I have taken only 2 principal components. You can take 3 or 4. So I have projected only 2 eigenvectors from this command on the data set. Input TF is my data set. Then I have plotted the 2D PCA result. Again, XPCA data 0th column and first column we have taken, and the color map and age colors defined here, and we have taken principal 2 components. You can see by the graph, we have 30 features to classify the data, but by taking only 2 components, we are mostly able to classify data because reds are on the one side and blues are on the one side. We can't display by the 5 components because it is not able in 3D. So only by 2 components and 3 components you can see. So that is the power of PCA. You can reduce your work to analyze the data by calculating the principal components. So that's how PCA will be done on a data. If you have any doubt, you can ask